Hi, I'm Professor Chow-Choong Ngeow. I graduated in 2005 from University of Massachusetts at Amherst. I specialize in observational astronomy in the optical. I'm also in charge the time domain and astroinformatics laboratory. I have a few students from master to PhD, as well as one undergrad student helping me on various projects. So what is a time domain astronomy? Normally, we will take a picture of the sky, what we call a static sky, shown on the left on this screen. However, if we can take a sequence of pictures in time, we will find there are some stars or other celestial objects will change brightness in time. So these are the objects that I'm interested to study. Those stars that change brightness in time. So what are those things? As this is a one summary slide, there are some objects like transient shown on the left will be explored as a supernova. There are some stochastic celestial objects such as nova, CV, and AGN will show variability but without any periods. There are some periodic stars, variable stars shown on the right of this plot, including pulsating star and increasing binary. Those stars highlighted in the red box are the stars that are the variable stars that I study in the past and as well as right now, including the long period variables, classical surface, and RRE. To less extent, I also study increasing binaries. Because these stars, variable stars, will show changing in brightness in time, we have to continue collect their data, right? And then we construct a line curve shown on the top right in this plot. So we have to do a lot of image reductions using various techniques. We have to apply astrostatistics, other statistic methods tailored to the astronomical needs. We have to collect many data that we have to do data mining to find out the interesting informations or the objects or stars that we are interested. Sometimes we have even do some machine learnings because the data set are just too huge for human to handle. So I using informations collected from this light curve, and then I make some correlations. One example is shown on the left. These are the R Rayleigh in the globular clusters. I measure their periods, measure their absolute magnitudes, and then construct what we call the PL relations for this variable star. Then I apply them to the different dwarf galaxies to measure their distance. So one example is shown on the right. Eventually, we can even use them to measure the expansion rate of the universe, the Hubble constant. In the past, I have been involved in the Ziki transient facility projects. Have several papers published on this, and in the futures, especially starting next year, in 2025, we will heavily involve in the Vera Rubin's Observatory of Legacy Survey of Space and Time. This is a very ambitious project, and almost all the transient time domain and transient astronomers in the world are very excited at this project. So if you have a chance to come to NCU, you have a chance to explore both the GTF data as well as the LLC data. Thank you.